Hello everyone. Today we will start our presentation on microprocessor 8085. First chapter is microprocessor based system with hardware interfacing. We already know what is hardware, and interfacing means interchanging and communication between hardware section and different section. That means section to section communication is known as interfacing. First of all, we need to know what is microprocessor. A microprocessor is a multi-purpose programmable clock-driven resistor-based semiconductor device that reads binary instruction from memory and accepts the binary data as input and processes the data and provides the results. That means it does multiple tasks. First one, it is multi-purposed. Then it is programmable, that means it's changeable. It's clock driven, that means clock can drive it. Then it is resistor based, that means it is connected with resistor and works on sometime resistors. Now it's a semiconductor device, that means it is made of semiconductors. Now it can read binary instructions, that means 0 or 1 instructions from the memory side and accepts the binary data as input and process the data and provides the results as an output. This is a simple diagram of microprocessor. Here it is connected with the memory input and output. In memory section it can both the bidirectional, but in input and output it's unidirectional. Microprocessor as CPU. The microprocessor is programmable integrated device that has computing and decision-making capabilities similar to that of some central processing unit, which is known as CPU. That means that a microprocessor is a computing device which can make the task of decision making by integrating some factors with by which it can work as the central processing unit, which is known as the CPU of the computer. CPU consists of the arithmetic logic unit, that is known as ALU, and the control unit. CPU contains various registers to store the data. The ALU unit performs the arithmetic and logical operation, instruction decoding and counting section, and also the controlling lines. The CPU reads the instruction from the memory and performs the task specifically. When the microprocessor works as CPU, then the system is called the microcomputer. That means if the microprocessor works as an integrated device which is as the computer, so that's the reason it sometimes when the microprocessor work as like as the CPU, then it is known as the microcomputer, because in your computer you have several devices such as input output devices, the processing unit, the arithmetic units. Those all are combined and then you can say this is a CPU. So if all the components are compact in a one system, that's the reason the system when it is called the microcomputer. By this diagram we can see that in the figure here we have the traditional block diagram of computer. In this computer we have the CPU portion, which is working material of the microcomputer, because in this CPU section we have the arithmetic and logical unit, which is known as ALU, and the control unit, which is works as the total volume of CPU, which is the combination of ALU and control unit, which this section can call as the microcomputer. In this diagram we can see that input is going on and the CPU is for processing the unit and gives the output. It is directly connected with the memory devices or the memory section by bidirectional connection. Now moving to the next diagram, we can see in this diagram that the microprocessor as CPU, which is the combination of ALU and control unit. In this section we have separate ALU and control unit, but in this section in between this microprocessor we have the ALU and control unit. That's the reason it is known as the microcomputer in this diagram too. We have as same as the input and output here, and which is connected with the memory with bidirectional lines. So this is the block diagram of computer with the microprocessor as CPU. By this diagram you can easily discuss about the difference between them. Now the microcontroller. In this microcontroller section we have the block diagram of microcontroller. In this section we first have the MPU, then the memory unit, then IO means the input and output section, some peripheral devices. AD converter means analog to digital or digital to analog converters, the timers for clock, and the serial IO for serial input and output devices. In this microcontroller section all separate components are integrated in one part. That is why it is known as the microcontroller. Microprocessor based system with bus architecture. The reason it is known as the bus architecture we will discuss in this diagram. It includes three components: microprocessor, IO input or output, and the memory, which is function to read-write memory or the read-only memory. Read-only memory is known as the ROM section. In this read-only memory, which is non-volatile, that means if you turn off the computer, it will save the data without the electricity. These components are organized around a common communication path which is called the bus. So this is the bus which is known here as the system bus. By this system bus which the devices are connected and the sections are also connected. This is the common communication path which is known as the bus. The entire group of components is also referred to as a system or microcomputer system, and the components themselves are referred as a subsystem. Here all the components are known as the subsystems. In this section we have a microprocessor. In this microprocessor we have the ALU, which is the arithmetic logical unit, then the register array, then the control unit, which is connected with the system bus and also with the input output port and all the memory instructions, which are ROM and RAM. Microprocessors. The microprocessors read the instruction from the memory and then communicate with all peripherals using the system bus. That is the reason by this system bus this microprocessor is communicating with all those sections. It controls the timing information flow and it also performs the computing task specified in this program. Microprocessor can be divided into three segments: ALU, arithmetic logical unit, then the register array, then the control unit. In this ALU or arithmetic logical unit section, we have this area is in the microprocessor where the various computing functions are performed on data. It performs such arithmetical operations such as addition, division, subtraction, multiplication, which can be done by some logical operations like as AND, OR, XOR, etc. Results are stored in the register or the memory section. In this register section, this area of the microprocessor consists of various registers identified by letters. such as B, C, D, etc. Those are known or called as some registers. Those registers are used to store temporary data which are generated by the ALU section and during the execution of the program. The control unit. The control unit provides the necessary timing and control signals to all the operators in the microcomputer. It controls the flow of the data between microprocessor and the memory and the peripheral section. That does means that the control unit in this diagram, this control unit can control the flow of data by the system databus to the input-output device, memory, and the microprocessor section. The control units control the flow of data. Now the memory section. The memory stores the binary information which is called as instructions and data. It provides the instruction and the data to the microprocessor on request. If it generates a request, then the memory will send the data to the microprocessor. It stores result and data from the microprocessor. It has two sections. The ROM sections, which is known as the read-only memory. It is used to store information that doesn't change. That means if you turn off the computer, there is no electricity, but the data will store. And now the read-write memory section, which is known also as the random access memory or RAM. It is used to store the information supplied by the user, such as programs and data. If you write something on the RAM, but suddenly you turn off the power of the computer without the electricity, RAM is a volatile memory that will format all your data, which is situated in the RAM. Now, the input and output section. The input section is to put the input of the to the microprocessor. It includes the keyboard, switches, the scanner, and also the analog to digital converter, which is known as the input section. Now, the output section, by that we can see the output. That means in such as our computer, we have LED, CRT, printers, etc., which are the output devices. It means that you are typing something in your keyboard, so that is the input for your CPU. But you are seeing the result in your monitor, that is the output section. Now the system bus. It is the communication path between the microprocessor and the peripherals. How does the microprocessor works? First, it fetches the data, then decode it, and then execute it. Fetching is to attempt the data, and then decode means to separated the data and generate the original data where it was encoded. Then executing the instruction is the execution section. So first section is the fetching, then decoding, and then lastly the executing section. During the entire process of microprocessor, the system bus first fetch the binary instruction and data from the memory. It uses registers to store the data temporarily and performs the computing functions in the ALU, that means the arithmetic logical unit section. Finally, it sends the out or results using the same databus lines. Here are some differences between microprocessors and some microcontrollers. First, you need to know what is microprocessor and microcontroller. In this microprocessor section, the microprocessor is the heart of the computer, but in microcontroller, it is the heart of the embedded system. It is one numerical architecture, and the microcontroller is not. In this microprocessor section, it is highly expensive, but microcontroller is lower expensive. It is microprocessor have high processing power, but the microcontroller doesn't. In this typical section, we have 32 or 64-bit microprocessors, but we have 8 or 16-bit microcontrollers. It has few bit manipulation instruction, but in microcontroller it has many bit manipulation instructions. In microprocessor we have the less number of pins, but in microcontroller it has the more multipurpose and functional pins. The microprocessor have the large space of address memory, but in controller it have the small one. In microprocessor have the less number of registers, but in microcontroller it has more number of registers. Microcontroller consumes lower power than the microprocessors. Microprocessor has zero status plug, but the microcontroller has no zero status plug. By an example, we can easily define which devices are microprocessor and which are the microcontrollers. In this section, the microprocessors are generally a separated processor which are connected with different type of peripheral devices and that can control it. But in microcontroller section, all other sections and peripheral devices are combined into an integrated system. That means the example of microcontroller, it is mainly the washing machine, MP3 player, those are the examples of microcontroller. But in the microprocessor system, it is mainly the personal computer or the PC. That's for today. Thank you. But in this section, the difference between microprocessor and microcontroller is very much important. Then another important topic is the fetching, decoding, and executioning, and also this diagram of microprocessor is very important for your exam point of view. This is the diagram of microcontroller. In this section, you can easily see that all the components are combined into a one section. But in microprocessor, that doesn't. The definition of microprocessor is very important for exam point of view. That's for today. Thank you.